Transformation, transformation, transformation. This one is a matrix transformation. So this should be relatively straightforward. So t of u has to equal a specific vector. Well, I think we should just guess and check this one, because that means this is going to be a times u is equal to that. So a is 1, 1, 0, 0, and all this stuff. U must have 3 entries, so something, something, something. So that has to equal 4, 4, 2, 2. So what's another way to look at this? Well, let's put some variables in here. We'll say this is like A, B, C. What it tells me is that A times that first column plus B times the second column plus C times the last column is 4, 4, 2, 2. So now it looks a bit easier to guess and check here. I'll take 4 here, and I'll take a 2 here, and here I'll take a nice 0. So U, which is the vector A, B, C, will be 4, 2, 0. Next question. Find a basis for the range of T. Okay, so this is a matrix transformation. So the range of T is going to be just a column space of A. So I'm going to find a basis for the column space of A. So I should use my usual algorithm. I should take the matrix A here and reduce it to echelon form. And what happens? I'm reducing this guy. Well, I hope you agree once I reduce that. I will get this matrix here. Okay, these two rows are the same, so one of them dies a horrible death. And these two rows are the same, so one of them goes away, leaving me with just this guy here. So I can see that I should choose my first and second vectors up here. So basis is equal to 1, 1, 0, 0, comma, 0, 0, 1, 1. Now C is the kernel, part C is the kernel. Kernel of T is just the null space of A. So I want a basis for the null space. So I'll take my reduced matrix here to help me solve AX equals 0. So I got this null space system here. And I get 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So again, using what I did up here, I got my information helping me there. So what does that tell me? Well, it tells me that x plus z is equal to 0 and y is equal to 0. So as usual, putting that into a vector, I get negative z for x, 0 for y, z for the free variable z. You see, z is a free variable. factoring out my z. There's my basis right there. So a basis is just a single vector, -1, 0, 1. Okay, last question, I believe, is onto, or 1 to 1. Is T onto, is it 1 to 1? Well, you look at the matrix right here, the reduced matrix, and you're counting pivots. Now I can see by looking at this matrix here that the reduced version of A, does it have a pivot for every row? No, it doesn't. So it is not onto. Does it have a pivot? Does it have a pivot for every column? No, it does not. Not 1 to 1.